absolute and conditional convergence for alternative series or non-positive series. We know the first formula here, that the absolute value of A plus B less or equal absolute value of A plus absolute value of B. And in general, we can write the rule number 2 here. The absolute value of A1 plus A2 plus A3 to AN less or equal absolute value of A1 plus absolute value of A2 plus absolute value of AN. So let's make N. Now, if N goes to infinity, this formula also correct. And we can write now the rule number 3, absolute value of sigma AI from 1 to infinity less or equal sigma absolute value of AI. Now, if the answer of this series is a number L less than infinity, so here also will be less than infinity. So if the series in absolute values converges, so my series here converges, and so sigma AI converges. In this case, I will call sigma AI converges absolutely. And if sigma AI converges, but this one is infinity, so it converges conditionally, not absolutely. So we have this theorem. So this is the result from the last rule, that if sigma absolute value of AI is a number or converges, then absolute value of sigma AI also will be a number or converges, then this sigma of AI converges. So in this case, I will call this series converges absolutely, because it converges and also the sigma of absolute value converges. So this is called converges absolutely, this one. Okay, let's resume. So let's take the definition. If sigma AN converges, then if the sigma with absolute value converges, then the sigma without absolute value will converges also. And in this case, this series is called converges absolutely or absolutely convergent. Now, if it could be that this one converges, but this one diverges. It's possible that this sigma is number and this is infinity. It's possible. In this case, I will call this series sigma AN converges conditionally, not absolutely. So in general, if sigma AN converges, we have two cases. Case number one, that also sigma absolute value of AN converges. In this case, this sigma is called converges absolutely, or if this sigma converges and the sigma absolute value diverges, in this case, I will say that sigma AN converges conditional. So let's take some exercises. In this exercise, I will take sigma minus 1 power n over n power 3 in absolute value from 1 to infinity. This is sigma 1 over n power 3 from 1 to infinity. And this is converges. This is less than infinity, because this number 3 here bigger than 1 using integral test. Let's remember the rule. What was the rule? Sigma 1 over n power b. This is always converges f from any number, 1 or 2, the beginning to infinity, if this b greater than 1. So now this number 3 here greater than 1, so it's in convergence. So my series sigma minus 1 power n over n power 3 converges absolutely. In this exercise, if I take the sigma of absolute value of minus 1 power n over n, so this is sigma 1 over n from 1 to infinity, from 1 to infinity. This is diverges. Why? Because also using integral test here, n power 1 over n power 1. And the rule said that sigma 1 over n power b equal infinity f b less or equal 1 using integral test. Integral test. Okay, so the series here in absolute value diverges. So what about without absolute value? So this series with sigma minus 1 power n over n from 1 to infinity converges using the alternative series test. Alternative series test. If you remember the rule of our alternative series test, sigma an from, so the rules are it must be one negative, one positive term, and it's the case here because minus 1 power n, and I have an. Now here, it must be an times, let's take an times minus 1 power n, okay? So the condition that an must be always positive, and it's 1 over n, always positive, and always an plus 1 less or equal an, so decreasing, and this is correct in this case. And also n approaches 0 when n goes to infinity, and this is correct. So because of this, this series converges. So finally, because it's converges, but in absolute value diverges, so the final answer, it's converges conditionally. Conditional. Let's take the next exercise. Let's take the general case. So we saw in alternative series test that in general, this is always converges. Converges by alternative series test. Because if I suppose an, it's 1 over n power b, so this term, it's always approaches 0, positive. When n goes to infinity, approaches 0, it's positive, and it's decreasing. So all the conditions are satisfied. So this series converges by alternative series test. What about the absolute value? So if I take in absolute value minus 1 power n over n power b from 1 to infinity, so I will have sigma 1 over n power b from 1 to infinity. So this is converges f b greater than 1 and diverges f b less or equal 1. So we have two cases. Let's write the final answer. For my series here, I have two answers, two cases. F b greater than 1, so converge absolutely. converges absolutely. But if b less or equal 1, so diverges converges conditionally. So converges conditionally. Converges conditionally. Okay. In this example, we can write this as sigma minus 1 power n times, because cosine n by it's minus 1 power n. We explained this before in an exercise before. Power times n over 3 power n from 1 to infinity. Let's take this in absolute value. So if I take sigma absolute value of minus 1 power n over 3 power n times n, so from 1 to infinity, so this will be sigma n over 3 power n. So if I call this sigma an, always from 1 to infinity. So let's use, for example, ratio test. Ratio test. What was ratio test? Was if I will take an plus 1 over an, if the limit is L when n goes to infinity less than 1, then converges. So let's calculate an plus 1 over an. What is an plus 1 over an? It's n plus 1 over 3 power n plus 1 divided by n over 3 power n. Then I will delete 3 power n with plus 1 with 3 power n. So after deleting, I will have 1 over 3 times n plus 1 over n. The limit of n plus 1 over n, it's 1 times 1 over 3. So the final answer, 1 over 3 less than 1. So now using ratio test, by ratio test, so this sigma of n over 3 power n from 1 to infinity converges less than infinity. So my series sigma n cosine n pi over 3 power n from 1 to infinity converges absolutely. The last example for today, it's this series. It could be written like this or like this. If I take it in absolute value, minus 1 power n over 3n plus 1 from 1 to infinity. So it's sigma 1 over 3n plus 1 from 1 to infinity. And in fact, this is diverges because if I use the limit comparison test, if I suppose an is 1 over 3n plus 1 and bn is 1 over 3n, let's take, or 1 over n, it would be 1 over n also. So if I take this, so what is the limit of an over bn? So I have here, it's 1 over 3n plus 1 over 1 over n when n goes to infinity. So I have limit here when n goes to infinity. So it's 1 over 3. So this answer is a positive real number. So using limit comparison test, limit comparison test. So these two series are the same. So both of them will converge or diverge. But I know that sigma 1 over n, which is sigma, diverges. Diverges. because 1 over n power 1 and 1 less or equal 1. Okay, so this diverges. So sigma an sigma 1 over 3n plus 1 also from 1 to infinity diverges. Because it's diverges, but without, this is an absolute value, diverge. But if I take it without absolute value, using the alternative series test, this sigma converges. So because in absolute value it diverges, so converges conditionally.